Now we are in part 7, reciprocal trigonometric functions. You know already SOHCAHTOA, sine, cosine, tangent. When I say reciprocal, it means 1 over. So sine, you know that it's opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. What is 1 over sine? We call it cosecant. You can write it, you can see it like this, cosecant or CSC theta. What is the reciprocal of cosine? It's secant, and the tangent is cotangent. It's very simple, guys. It's not hard at all. Now we know already from some preceding videos that I proved already for you the famous trigonometric formula sine squared theta plus cosine squared theta is equal to 1. Now from this one we can deduce two more formulas. If you divide all this equation by sine theta, you will have sine squared, by sine squared over sine squared is 1, cosine squared over sine squared is cotangent, 1 over sine squared is cosecant squared. So now I have a relation between cotangent and cosecant. And if you divide all by cosine squared, you will have sine squared over cosine squared is tangent. Cosine squared over cosine squared is 1. It's equal 1 over cosine, it's secant squared theta. Now let's move, guys, to the application. It's very easy and very simple. We need to evaluate exactly the secant pi over 6 minus cotangent pi over 3. Secant, this means 1 over cosine, so 1 over cosine pi over 6 minus cotangent. I can either do it 1 over tangent or cosine over sine. We know those angles. The pi over 6 is one of the famous angles, and it's quadrant 1, so the cosine radical is 3 over 2. And now cosine pi over 3, it's half, sine pi over 3 radical 3 over 2. And then when I switch, it's 2 over radical 3 minus 1 over radical 3. And then it will be 2 minus 1, 1 over radical 3. You can rationalize by multiplying up and down by radical 3. And my answer will be radical 3 over 3. The second one, cosecant minus 2 pi over 3. Also, it's 1 over sine minus 2 pi over 3 plus 2 times, what is tangent 7 pi over 6, 1 over radical 3. And then I will have the answer as minus 2 over radical 3 plus 2 over radical 3, so it's 0. It's very simple. We just are calculating and replacing. Simplify each of the following expressions to give a single trigonometric function. It means the answer should be one trigonometric function: sine, cosine, tangent, cotangent, secant, or cosecant. So we need to memorize the formula. Cosine theta, sorry guys, cosine theta times tangent theta. So we know cosine, we cannot do anything with cosine. Tangent, it's sine over cosine. So if I replace it and then I simplify, and the answer will be sine theta. B, cotangent times secant. We know cotangent, it's cosine over sine. Secant, it's 1 over cosine. We simplify, it's 1 over sine. What's 1 over sine? It's cosecant theta. Cosecant theta, tangent theta. Cosecant is 1 over sine, and tangent is sine over cosine. We simplify, it's 1 over cosine theta, so it's secant theta. D, cosine theta, secant squared, sine theta. Cosine theta, I cannot replace it by anything. Secant squared, it's 1 over cosine squared times sine. We can simplify. I will have sine over cosine, so it's tangent theta. This exercise will let you practice the formulas and see if you know it and you memorize it. Tangent times cotangent, I can either replace sine over cosine, cosine over sine, or by 1 over tangent, and then we simplify, so I will have just 1 over sine. And what is 1 over sine? So this expression is 1. 1 over sine, it's cosecant theta. The last one, tangent, it's sine over cosine times cosecant, it's 1 over sine. We simplify 1 over cosine. What is 1 over cosine? Secant theta. Let's move to exercise 4. Given that cosecant theta is 13 over 5 and theta is between pi over 2 and pi, find the value of cosine and cotangent. Every time I have an exercise like this, before I start to calculate, I need to determine the quadrant to know the sign of my trigonometric function that I need to find. I'm working in quadrant 2. It means I have cosine is negative and sine is positive. Tangent is negative and cotangent is negative. But I really care about sine and cosine. The cosecant will give me directly sine theta. And how are we going to find from sine cosine from the famous formula? Sine squared theta plus cosine squared theta is equal to 1. I replace and I solve. You will have cosine squared theta is equal to a number. So you just take the negative because I'm working in quadrant 2. I got sine and cosine. How do you find cotangent? You can put cosine over sine minus 2 over 13 over 5 over 13 minus 12. Sorry, so it's minus 12 over 5. Number 5. I have secant. I'm working between pi and 2 pi. It means I'm in quadrant 3 and 4. I need to find the value of cosine, tangent, and sine. It means cosine could be negative or positive. But since they gave me secant will give me directly cosine, so cosine is negative. So here I'm taking the negative for cosine. But I'm sure that sine is also negative in quadrant 3 and 4. So I just have the question mark for cosine. Is it negative or positive? So directly it's negative because secant is negative, so cosine is negative. Now to find sine, I do sine squared plus cosine squared is equal to 1. We solve and we take the negative value for sine. How do we find tangent? Sine over cosine, minus 3 over 5 over minus 4 over 5. So the answer is 3 over 4. Move to number 2, part exercise 6K. Also in this part, I just wrote on purpose this famous formula cosine squared plus sine squared theta is equal to 1. And I need to calculate the following expressions. Radical 1 minus s squared means radical 1 minus sine squared. What is 1 minus sine squared? If I look here, it's radical cosine squared. And you know, radical anything squared gives me absolute value of the expression. I cannot write, guys, cosine theta because I'm not sure if it's positive or negative. So I need to keep it cosine, absolute value. If it's positive, it's going to give me the same answer, cosine theta. And if the inside is negative, it's going to give me the opposite of the inside. This minus doesn't mean that it's negative. No, this minus means that it's opposite of the inside. So here, if the answer was, for example, here minus 0.1, absolute value is going to be minus 0.1, so it's 0.1. The answer should be all the time positive. In B, as it's sine theta over 1 minus sine squared. Again, what is radical 1 minus sine squared? We did it now. It's either cosine or minus cosine. So either it's sine over cosine tangent or sine over minus cosine, it's minus tangent theta. Part C, radical 1 minus cosine squared over cosine theta. Again, radical sine squared theta, it's absolute value of sine theta. And absolute value can give me either it's exactly the same as it is. If sine is positive, the answer is it's exactly the same, it will give me sine. But if the answer sine is negative, the answer it's opposite of the inside. So it's minus what is inside. So it's gonna be also positive. This minus again doesn't mean it's negative, it's opposite of the inside. So either it's sine over cosine, tangent, or minus sine over cosine, minus tangent. D, I have cosine of 1 minus cosine squared. 1 minus cosine squared, again, it's sine squared. So it's cosine over sine times 1 over sine. This is cotangent times cosecant theta. We move to E. What is radical 1 plus tangent squared? 1 plus tangent squared is secant squared, absolute value, and also it gives me secant or minus secant. Again, here the same. This one will give me absolute value. So it's either sine over cosine over secant means times cosine or minus cosine. So the answer is either sine theta or minus sine theta. How I got this one? Tangent sine over cosine times what is 1 over secant cosine. Okay, guys, don't be lost. Exercise 2. Again, same thing. I need to simplify the following expression. X squared, it's a squared sine squared theta minus a squared. Now, if I factorize by a, I will have a squared factor of sine squared theta minus 1. What is sine squared minus 1? It's minus cosine squared, it's not cosine. Look at it here. Sine squared theta minus 1. So I would take the 1 here, the cosine to the other side. So it's minus cosine squared theta. And then the answer is minus a squared cosine squared theta. B, again, it's b cotangent theta b squared plus b squared cotangent theta. Inside, we're going to factorize by b. We know that radical, here I have square root of a times b. I can switch, I separate radical a times radical b. What's radical b squared? Absolute value of b. What's 1 plus cotangent squared? It's cosecant squared, so absolute value, absolute value. So either both are, this one is plus and plus, so either the answer gonna be b squared cotangent squared cosecant theta or minus b squared cotangent, sorry, not squared, cotangent theta cosecant theta. See the same, I factorized absolute value times absolute value. So either it's negative, the answer, or positive. 1 over cosecant sine or minus sine. I'm going fast because it's very easy, guys. Again, here I'll factorize by a squared, absolute value of secant squared minus 1 is tangent squared, absolute value of tangent. So either the answer is a over a sine cosine times cosine, so it's sine theta or minus sine theta. Exercise 3. Solve the following equation for all the value of theta between 0 and 2 pi. So just we need to it between 0 and 2 pi. So we need to write plus 2k pi. The first equation, if you look at it, guys, I have in A, I have cosine and sine squared. And I need to have all the same variables. So which one we can change? And sure, we cannot change cosine, so I'm going to change sine. Sine squared, I will replace it by, first I took it all to one side, so I have 2 sine squared theta plus 3 cosine theta minus 3. Instead of sine squared, I will write 1 minus cosine squared. We develop 2 times 1, 2, 2 minus 3, it gives me minus 1, minus 2 cosine squared theta. This is a quadratic equation. I can put it on my calculator. So this one will give me 1.5. Cosine theta is half, so it gives me 0 and 2 pi. Cosine theta, 1 gives me 0 and 2 pi. Half, it means positive. I'm in quadrant 1 or 4, so it's alpha or 2 pi minus alpha. So it's pi over 3 or 2 pi minus pi over 3. So, and then it's 5 pi over 3. B, secant 1 over cosine equal to 2. It means cosine is half. It's the same as this case. So pi over 3 or 5 pi over 3. Again here, cosine and sine. So I need to change one of them to be the same variable. So I'll change cosine as 1 minus sine. I'm a quadratic equation. Gives me 2 roots. Minus 1 and plus 2. Sine cannot be because sine and cosine, you know that it's all the time between minus 1 and 1. And sine theta minus 1, this one is here. Those what the 0, the 1, the minus 1 are those here. So it's here, so it's 3 pi over 2. I just have one value. For those here, I just have one value. For the 0, 1, minus 1, sine and cosine, it's just those on the axis. Also the same, I have secant and tangent. I need to change it to one variable. Which one will change? The secant squared. It's 1 plus tangent squared. Then I took all to one side, minus 1 minus tangent theta. Now here I have a second degree equation. We can factorize it, or you can do delta. A is 1, B is minus 1, C is 0. So it gives me tangent is 0 or tangent is minus 1. Tangent theta is 0. Also, it's one of those. So I have it's either 0 or 2 pi. Tangent theta is 1 positive. It means quadrant 1 or quadrant 3. So it's alpha and pi plus alpha. So pi over 4 and pi plus pi over 4. So 5 pi over 4. I'm going fast because those we did in the preceding lesson, guys. The same here. We replace. I will let you take your time doing it by yourself. Also, we replace and we solve quadratic equation. Secant gives me cosine half. We did it before. Minus 3 is impossible. I'm going fast because I want to finish number 4 too. F. Also here we replaced, I need to have the same variable, cotangent cosine over sine, and then I will have here cosine squared plus 8 minus 7 over sine, same denominator. A fraction is 0 and my numerator is 0. So I will have here, this is my numerator. I need to have the same variable. So instead of cosine squared, I'll put 1 minus sine squared, again quadratic, 2 roots, 1 is rejected. Sine is positive, it means quadrant 1 and quadrant 2, so it means alpha and pi minus alpha. We move to exercise 4, the last one. Simplify. Cosecant theta plus 1 plus cosecant theta minus 1. This is an identity. It's a plus b, a minus b. So I can replace it by a squared minus b squared. So cosecant squared minus 1 and cosecant squared minus 1 gives me cotangent squared. Part B. Here, if you look at it, you can see that it's as here it's 2ab. So 1, I can replace it by cosine squared plus sine squared. And I can see that I have an identity now. It's a squared plus b squared plus 2ab. And it gives me a plus b squared over sine theta plus cosine theta. Now I can simplify, and I got it's cosine theta plus sine theta. The last one, 2 tangent theta plus secant squared theta. I replace secant squared by 1 plus tangent squared. And I can say another identity. This is a squared plus b squared plus 2ab. So it's a plus b squared over sine theta plus cosine theta. Now all of it squared. And then instead of tangent, because to be able to simplify, it should be all sine and cosine. I will write sine theta over cosine theta. And then now I can do the same denominator here. So I will have sine theta plus cosine theta over cosine theta times the inverse of this one. So times 1 over sine theta plus cosine theta. We can simplify here. This squared is for here now, guys. So we can simplify. It's going to be 1 over cosine squared theta. So it's secant square theta. That's it. And in the second video, we'll do the last part and this lesson. Guys, it's easy. Watch it again. Take your time. It's very easy. It's not hard at all.